Hello, dreamers of the cosmos. Welcome back to Bedtime Universe, your celestial refuge among the stars, where we close our eyes, drift beyond the noise of Earth, and listen to the quiet stories written across the night sky. Tonight, we follow the path of a silent traveler, a wanderer from another star system, passing through our cosmic neighborhood for only a fleeting moment. It's a story of mystery, of discovery, and of how one small object reminded us just how vast and connected the universe truly is. So, find a comfortable place. Let the darkness around you turn gentle. Take a deep breath and let your mind float among the stars. This is The Silent Passenger, a story from beyond our solar system. They found it on a July morning when the southern sky still smelled faintly of winter and the Chilean observatory's domes were yawning awake. The alert came across a thin, efficient line of code. A new detection flagged by Atlas, marked as unusual, and then, as always, verified by a second, then a third scan. For the astronomers who lived by such alerts, the name that blinked into existence, 3I divided by Atlas, felt at first like an ordinary catalog entry, another dot on a sky the world had turned into a ledger. But very quickly, ordinary became impossible. From the first images, it refused to belong. It arrived on a track that did not bend to the sun's gravity the way comets from our own Oort cloud did. Its path was a sharp arc, a clean hyperbola that said, "With cold geometry, I am coming from elsewhere." The word interstellar traced itself through the lab like the shadow of a comet's tail. A rarity. A text that made scientists hold their breath in the same way sailors once did when sighting a whale on the horizon. Marta was the first person to say it out loud in the observation room. She had dark circles and a messy bun, and a way of naming things that made them sound less like data. "A visitor," she said. "A proper visitor." They called her team together, and their excitement was practical and stubborn, the kind that makes people in the middle of the night refuse bed. Telescopes across continents swiveled toward the coordinates. Radio dishes woke. Infrared cameras stretched their sensitivity. Even amateur stargazers, sipping coffee in suburban backyards, began to point their lenses and whisper. At first the object was a bright, stubborn pin of light, small but steady. Then, as equipment grew more patient and the sun pulled it into a closer dance, the pin yielded a faint haze. A coma, a cloud of gas and dust, bloomed around the nucleus, the classical sign of cometary activity. Yet the usual rules of comets were written in old ink, and 3I divided by Atlas was in the awkward present tense. The composition readings came back like gossip, an excess of carbon dioxide. CO2, a coma dominated by gas, not often seen so prominently in comets from our neighborhood. Water vapor was present, but not like the main voice. It was an understudy. There was also a strange anti-tail, a fan of dust that seemed to point toward the sun rather than away, a trick of perspective and particle dynamics, but also an argument the object made against simple explanation. It suggested that the dust was not merely following the sun's invisible wind, but was shaped by larger, quirking forces. Perhaps a rotation that flung material in particular patterns, perhaps a layered structure of volatile ices releasing in bursts. For every chart and spectrogram, there was an equal measure of wonder. The university radio room turned into a place where hypotheses were laid out like maps, each group sketching the same terrain and highlighting different contours. Some said, natural body, a comet from a cold, faraway system where ice chemistry favors CO2. Others, with wilder pens, suggested exotic surface processing or rare interactions with interstellar radiation fields. Nobody, in the room at least, said anything that approximated certainty. Outside, on the night the object made its closest approach visible to backyard telescopes, thousands stood with their necks cricked, eyes damp from the cold air, and the weight of their own smallness. It was impossible to look at the sky with a human's heart and not feel moved. The comet's tail was a pale smear, a ghostly brushstroke on the canvas of stars. Lovers pointed hands, children made wishes, some whispered, with a superstition as old as myths, that the sky had sent a messenger. Marta, who had spent much of her life learning to be exact with language, sat in a corner of the control room and wrote something down in the margin of her notebook. "We are the recipients." That notation felt less scientific and more humane. A recognition that we were, for a time, on the receiving end of an artifact from somewhere that was fundamentally not us. The scientific rush was one thing. Another thing was the public imagination. Newsrooms lit up. Social feeds churned with grainy captures and schematics drawn by hand. People who had never read a paper on orbital mechanics debated whether 3I divided by Atlas could be a probe, a relic, a natural object, or an artifact of imagination. The word alien spread like static, sometimes used carefully, more often as a spark to stoke attention. The scientists learned to behave like mediators. They leaned into the method that had brought them this far: observation, measurement, peer review. They developed narratives built from spectra rather than speculation. Press conferences began to look like geology lectures for the sky, calm, patient, and full of conditional verbs. They were careful, because speculation could be infectious, and because the responsibility weighing on their shoulders had nothing to do with fame, and everything to do with truth. As days passed, something else showed. The coma's brightness increased in pulses. The dust ejection was episodic, not continuous. Images suggested jets, localized plumes of material escaping from fissures, each puff a kilometer-scale exhalation. The nucleus, which remained unresolved by all but the most powerful instruments, seemed to fracture light and intent in ways the models did not predict. The antitail persisted, and with it the suggestion that we were not looking at a simple, homogeneous rock, but at something textured, weathered by a history we could only imagine. Marta and her colleagues began to feed the data into simulations. They spun models of the object's thermal profile, its rotation, its possible interior. Each simulation was a story. One showed a core layered with volatile rich strata, pockets of CO2, ice sealed beneath crusted regolith, like photos in an album. Another imagined amorphous, porous conglomerates that, when heated by the sun, released gas in sudden bursts. These models were not answers. Rather, they were maps that traced plausible features on a world that refused to be directly seen. In the quiet hours before dawn, Marta would walk out to the concrete telescope platform and breathe in the thin air. The sky there felt close, neighborly in a way most city skies never could be. She would remind herself that everything they learned about 3I divided by Atlas came from photons that had traversed unimaginable distances. The object's arrival was a conversation in light, and each new measurement was an excerpt that allowed translation of a language only half remembered. News began to pick up the framing that the comet was doing something no comet had ever done. That phrase gleamed in headlines. It was true and not true. Every comet is in some sense unique, and yet 3I divided by Atlas carried a set of characteristics. Its composition, antitail, episodic jets, arranged in a way that made patterns from the unfamiliar. For the public, the novelty was intoxicating. For scientists, novelty was an invitation to test theories and to be humbled. Among those who watched the comet's ledger of behaviors closely was Dr. Ian Cho, a planetary spectroscopist with a gift for metaphor. He had a habit of writing letters to colleagues, as if they were to the cosmos. He drafted a note to Marta that began, "If this object is a letter, what does its paper tell us?" He argued that the high fraction of CO2 might reflect a protoplanetary disk chemistry, different from our own, a fingerprint of the environment that forged it. If so, then studying 3I divided by Atlas was like reading a geological survey from another system. Each molecule was an echo of conditions under alien stars. While they argued and modeled, some engineers quietly proposed more ambitious plans. The idea was not to chase the comet. Its velocity and hyperbolic escape would make interception wildly expensive and technologically challenging, but to send small, fast flybys or to point more sensitive instruments at it during its brief brightening passage. There were programs that could repurpose satellites and telescopes, tweak observation schedules, and chase shadows on the sky with an urgency unfamiliar to bureaucrats. The thought of hardware paying attention as humanity watched felt appropriate, as if both machines and people should witness the same event. Then there were the philosophical consequences, the late-night conversations about what it meant to have visitors at all. A philosopher joined a symposium and asked, gently, if our eagerness to assign agency to 3I divided by Atlas revealed more about our anxieties than about the object itself. When we ask whether a comet is an instrument or an artifact, are we looking for proof of companionship, or are we merely searching for reassurance that we are not alone? The question hung in the hall like a cometary dust grain, tiny but luminous when the light hit just so. The comet's behavior became a public liturgy. People in small towns planned viewing parties. School children drew representations of its tail. Poets tried to catch its motion in verse. On streaming platforms, amateur astronomers with shaky mounts uploaded time-lapse compilations that turned the passing into a kind of choreography. A brightening, a bloom, an anti-tail that resolved into grainy ribbons. Each video was an attempt to capture the ephemeral. As observational months failed to stretch into the years required for close study, the urgency grew. Scientists published rapid open-access preprints, each one a scaffold of data and polite conjecture. The preprints themselves became collective storytelling graphs, spectra, and cautious prose, forming sentences that could be argued and tested. The scene was a laboratory of transparency. When the world's telescopes were aimed at a single guest, the academic community realized that the fastest path to understanding lay in sharing. The comet, for its part, continued to be inscrutable. On a day when the comet was closest to the sun perihelion, the nights were short and the instruments were busy. The heat of the inner system flicked volatile ices awake, and the jets were more pronounced. The anti-tail sharpened to a fine, almost deliberate streak. Spectroscopy showed fluctuations in the relative abundances of certain species. At times, the spectrum hinted at complex organics molecules, whose signatures are the same building blocks of life's chemistry. But those signals were faint and ambiguous, swallowed sometimes by noise and instrumental quirks. The spectroscopists were careful not to overclaim. They annotated frequency bands with long lists of uncertainties. Still, the possibility that primitive, carbon-based molecules were part of the mix fed both science and imagination. It reminded everyone of how small the difference between alien and familiar can be at the molecular level. The chemistry that builds prebiotic molecules is not proprietary. It is universal, a consequence of carbon's affinity for forming chains and rings when given energy and time. In this, 3I divided by Atlas was both alien and a cousin. The more they learned, the more the object's past opened up as a set of hypotheses. Perhaps it had formed in the cold outskirts of a young star's disk, a family of planetesimals shuffled into interstellar space by gravitational tugs and chaotic interactions. Perhaps it had once orbited a dim red star and been flung outward by a passing giant or a violent birth of a planet. These were stories, and stories need not be precise to be powerful. As the comet retreated, its velocity increased, and its profile dimmed into a blur once more. People marked the moment with a quiet grief. There is a human tendency to mourn what is transient, even when the transient is a tumble of rock and ice. It had arrived and taught. Now it would leave and be reduced to new points in new datasets at other observatories. For some, it was a farewell. For others, it was the end of a conversation that had never truly been two-sided. In the months after the comet's passage, debates persisted. Was 3I divided by Atlas truly exceptional, or did our improved observational network mean we were now more likely to catch such interstellar wanderers? The answer, like most answers, held shades. The detection capabilities of modern telescopes are unprecedented, and so the number of known interstellar visitors rose by the virtue of tools. Yet the composition and behavior of this object were distinct enough to prompt papers and panels that argued for targeted future surveys, improvements in early detection cadence, and increased coordination among observatories across the globe. Marta, when interviews came, tried to keep her public voice steady. She knew the danger of myth-making, how casually we can turn a scientific object into an omen, a totem, or a stealthy visitor with intent. It came, she said in a televised roundtable, and it brought its own chemistry, its own shape. We measured, we observed, we learned. The universe is full of surprises. Part of science is learning to listen and then trying to understand what you heard. Her personal notes, however, were different. She kept a private journal, a ritual that had little to do with professional pride and more with the need to anchor oneself when the sky rearranged its furniture. In those pages she wrote not as a scientist but as a witness. She described nights when the northern sky had been clear, when the comet had been a whisper and the world had felt like an audience to a cosmic performance. She wrote of the enormity of being the species that could not only watch, but also, with instruments and reason, begin to read these visitors' pages. The comet's legacy took root in smaller, subtler ways. Curricula adapted. University courses added modules about interstellar objects. Amateur astronomy societies saw a surge in membership. Funding agencies, sensing public interest, approved grants for better detection algorithms and for dust analyzers that might ride future craft. The passage of 3I divided by Atlas had, in its brief performance, shifted priorities. It had showed where attention could be profitable in both knowledge and wonder. There were still late-night forums where people allowed themselves a different kind of speculation. An old professor posted a thread that posited a thought experiment. If an interstellar object were intentionally engineered, what would its designers reveal first? The ensuing discussion was civil, imaginative, and always respectful of the boundary between speculation and evidence. The thread ended, as such things often do, with a collective shrug and a renewed appreciation for ambiguity. In the long view, the sky swallowed the object as it hurtled away on its eternal trajectory. New telescopes in space and on the ground were commissioned, not only to find more such travelers, but to be ready with richer instruments when the next one came. The scientific community had learned lessons about rapid collaboration, open data sharing, and the spiritual economy of discovery. That it is worth investing in the capacity to notice and to respond. Years later, in a panel at an international conference, Marta sat among colleagues as young scientists presented papers on molecules found in 3I divided by Atlas's coma, on dust textures that suggested a history of collisional gardening, on isotopic ratios that hinted at a stellar nursery cooler than our own sun's birthplace. Each presentation was a thread, and together they wove a tapestry more detailed than the sketch the first nights had allowed. The comet, that had once been a quick brightening in the southern sky, had now become a chapter in a longer story about exchange, about the way our system receives and sometimes returns material from its galactic neighborhood. At the conference, they celebrated the collaborative ethos the discovery had galvanized. Journals published special issues. Schools taught modules. The public retained a memory of that strange anti-tale, and the phrase 3I divided by Atlas entered amateur lexicons, the way a song enters a neighborhood. It was hummed in coffee shops, and mentioned with easy nostalgia on social platforms. But even with all the analyses and models, something remained irreducible. The sense that an object had come from elsewhere and had, for a brief moment, brushed our attention. Science had recorded its chemistry, charted its motion, and argued about its nature. Yet the most human reactions were not in the graphs. They were in the small ways people had looked up together and felt, for a time, participants in a cosmos that continues to move and to send. Marta kept a small printed photograph taped into her notebook, a grainy but honest image of the comet's faint anti-tail. Beneath it, she had written a single line. We were shown a page. She meant the sentence, both literally and metaphorically. 3I divided by Atlas had been a page torn from another world's archive, drifting through space until, by a chain of chance and calculation, it was visible to us. Reading that page required instruments and expertise, yes, but it also required a kind of cultural humility, an admission that the universe does not exist solely as backdrop to human affairs, but as an active participant in a broader ecology of exchange. As years passed and more interstellar visitors were detected, some smaller, some stranger, some blunter in their composition, humanity learned to listen more skillfully. We built telescopes that could parse more complex spectra, algorithms that could distinguish subtle peculiarities, networks that coordinated observation across time zones and continents. Each object taught us not only about chemistry and dynamics, but also about a method of attention. Be ready, be modest, and above all, share. Sometimes, when Marta walked beneath a clean, unpolluted sky and noticed a faint streak that could have been anything, she smiled at the memory of that first July morning. She remembered the hush that had spread across the world's observatories as 3I divided by Atlas was named and catalogued. She remembered the mixture of nerves and delight, the way humanity's curiosity had felt like a ship turning toward a distant flare. If there was an ending to this part of the story, it was that we had been changed more than the comet. 3I divided by Atlas, as it left, had taken with it a small portion of our attention. It had scattered our questions into the dark. In return, it left a little more than tracks and spectral lines. It left a new habit, the habit of looking up and considering, with patience and rigor, the objects that pass through the spaces between the stars. That habit itself was a kind of promise. It promised more encounters, more pages from other archives that might one day tell us things we had not thought to ask. It promised that the sky would continue to be a place not only of mystery, but also of method, an arena where wonder and discipline could meet, and through that meeting, enlarge what we know of the universe and of ourselves. Late one evening, years after the comet's passage, Marta found an old recording of the first broadcast of 3I divided by Atlas's detection. She listened to the clipped voices that had been younger then, the taut cadence of excitement and an emotion she could not name rose in her chest. Gratitude, perhaps, or the small, sharp pleasure of having been present when the universe opened, briefly, to show us something new. She turned the recording off, looked up through the window at the band of the Milky Way, and whispered, as one might to a neighbor, "Come again." And so, the silent traveler drifts away, back into the deep ocean of interstellar space, leaving behind only a shimmer of memory and a quiet reminder that we, too, are travelers here. Every now and then, the universe sends us a visitor, not to answer our questions, but to remind us how beautiful it is to keep asking them. Perhaps 3I divided by Atlas was never meant to speak, only to pass by and to show us a single, glimmering page from another world's story. As you rest tonight, imagine yourself floating beside that comet, weightless, calm, and endlessly curious, watching the stars slide by in infinite silence. Because out there, beyond every horizon, the universe is still writing, and sometimes, if we're quiet enough, we can hear it whisper. Thank you for joining this journey tonight, here on Bedtime Universe, where dreams are written among the stars. Sleep well, traveler. Hello, dreamers. Welcome back to Bedtime Universe. Lay your head down, breathe slowly, and let the room around you dissolve into a soft, velvety hush. Tonight I will tell you not one quiet tale, but many threads of human curiosity and cosmic mystery braided together like a slow, luminous rope that pulls us out beyond our familiar shore. These are stories that have traveled, in some form, from watchful telescopes and busy laboratories, from deserts where astronauts learn to listen to the wind, from the clever hands of students sketching life support systems on napkins, and from the deep, patient light of newborn worlds. Each thread is a small miracle. Each breath you take now travels the same physics that carry starlight. Let us begin. Imagine a field of dust that is almost too fine to notice, a gossamer of grains smaller than a fingernail, circling a young star. For eons, the dust whirls in slow, patient currents, colliding, sticking, growing. Sometimes those grains gather into pebbles, then into rocks, then into something with gravity, with a faint warmth, with a tiny, greedy appetite for more. In the glow of distant instruments, we have not just imagined, but watched this process in motion. Recently, the human eye in space, the James Webb Space Telescope, trained its golden gaze on a massive planet, encircled by a disk of dust and gas, and found evidence that within that ring, the raw chemistry to build moons is present. It is the very stuff of small worlds, hydrocarbons and carbon dioxide, the whisper of molecules that, over cosmic time, might clump and spin into moons of ice and rock. We are watching, in a way that would have seemed magical to earlier generations, a construction site for moons around a faraway planet named CT-CHAR-B, some 625 light-years from our own sea of blue and green. Now let that image fold into another. Picture a planet so recently formed that it still glows with the heat of its own birth. Imagine light wrapped around it like a shawl, a fragile violet halo in the cold, dark. Astronomers have been lucky enough to capture direct images of such newborn worlds. These are not the distant, cold rocks that circle in silence around our own Sunday. These are infant giants, flecked with warm light, waltzing within the very rings that made them. One of these discoveries was announced with the wonder of a discovery alert. A baby planet photographed in a ring around a star. A minute, hopeful glow that tells us the universe is still busy making itself. The tidings came from careful telescopes and patient analysis, and they remind us that creation is not only in the past. Creation keeps happening, now, elsewhere, as you listen to this story. From the quiet work of the universe, we return our gaze, gently, to the busy, tender work we do for ourselves. In Houston at Johnson Space Center, there are new faces now learning how to be guardians of our ventures beyond the air. A new class of astronaut candidates has been welcomed, 10 in number, each chosen for a life devoted to training, to study, to listening. They learn to move without gravity, to care for each other in small, crucial ways, to swim through simulators that mimic a world with no flaw. They learn wilderness survival, so that, if the unexpected comes, they may adapt with calm and skill. Think of them standing at dusk, tied to suits that smell faintly of rubber and new fabric, watching the same moon you watch from your window. They carry not only their own hopes, but 1,000 small ambitions of engineers who made their rockets lighter, of teachers who once read them stories about the stars, of communities that believe in possibility, and yet, selection alone does not put humans back on the moon. There is a kind of gentle insistence in laboratories and university classrooms everywhere. Teams of learners and dreamers, building things that could one day become lifeways on other worlds. NASA's Human Lander Challenge stands like an open door. It invites students and innovators to propose life support systems, to imagine how a group of people might live and breathe and sleep in a place that has no atmosphere to hold them. The call is practical, and it is poetic. It says, "Help us build homes of air and warmth for people who have not yet set foot on the lunar dust." It asks for pipes and filters, for ways to manage heat and the cold, to scrub carbon and carry water where there was none. It is a challenge and an invitation to stitch human ingenuity into the cloth of exploration. The design sketches and late-night cups of coffee that form in response are as much a part of human exploration as rockets and telescopes. Now, allow the story to drift a little further outward until the dark is not empty, but full of steady points of light, each a story. The James Webb Space Telescope has been mapping more than single planets and disks. It has turned its instruments toward great nurseries of stars, places where clouds of gas and dust coalesce under gravity's patient pull to ignite the first clear flame of a new star. In a region called Pismis 24, Webb has taken a sparkling image of star birth, a tapestry of orange and near-infrared light that shows clumps of matter arranging themselves into tomorrow's suns. Each such image is an atlas of origin, a quiet ledger of the ways matter organizes and becomes luminous, a reminder that even violent births can be beautiful. The telescope's images are not just pretty pictures to hang in a gallery. They are evidence, data, that allow scientists to ask how galaxies are built, how thick stellar disks form, how environments shape evolution. In these portraits of birth, we can almost hear the slow exhale of the universe as new heat begins to beat. The human stories loop back and forth with these cosmic events. Students building lander prototypes imagine future astronauts walking across regolith stirred by engine plumes. Engineers who study particle physics design shielding to keep that astronaut's heart beating steady against invisible rain. Flights take to our own atmosphere to measure the air we breathe, with scientific instruments tucked into aircraft to sample tiny particles and trace gases. The same curiosity that has us peering at newborn planets also leads us to measure the breath around our cities and the flow of water after a fire. The data that orbiting satellites send down help protect the people on a hillside downstream from a burned watershed. Science is a conversation between distant glories and immediate care between the stars and the soil. Imagine a lab at night, the lights low, screens glowing like constellations. A team of scientists studies spectral lines, thin patterns of light that reveal the chemistry of a planet-forming disk. The patterns tell of hydrocarbons and simple organics, the building blocks of complexity. Elsewhere, a group of students assembles a prototype for transferring fluid without losing heat. A little farther on, an astronaut in training slides out of a simulator and rubs her hands together, thinking not of the instruments she will one day use, but of the person who will rely on her care in the small hours of an alien night. The tether that binds these moments is responsibility. Each discovery is met with the question, how do we make this knowledge useful? How do we keep people safe while they explore? Let us drift now past formalities and into a simpler human moment. Picture a child somewhere on Earth, wrapped in a blanket and gazing at a tiny LED projector on the ceiling that shows slow, twinkling stars. Perhaps she has heard of the Webb telescope's images. Perhaps she has read a small headline about a planet being photographed in a ring around a star. In that child's small mind, the universe becomes an immediate companion, a place of friends waiting to be met. That is the true power of what we do when we send telescopes into the dark. We give the next generation an expanded map of what is possible. You might imagine that space agencies and large telescopes are remote, their work cold and technical. But the truth is softer and stranger. It is a story of many hands, of late-night code that finally runs, of metal surfaces polished by apprentices, of teachers who press a paper telescope into the hands of a child. When Webb returned images of star formation, people anywhere with an internet connection could pull those images like a blanket over their lap and study them. The images cause wonder precisely because they connect the very small with the very large, the grain of dust to the gleam of a newborn Sunday. Think now about silence in space, where sound cannot travel the way it does on Earth. In the quiet between stars, telescopes listen in other ways. They read the fingerprints of light. They read shadows and cooling curves and the faint warmth of gas. The story of CT-Char b and its moon-forming disk was written in such fingerprints. It required patient observation and careful analysis. It is also a story that tells us something about the potential for complexity in other systems. It says that the processes that once formed our moon or shaped our planet are not unique. Elsewhere, in a dark ring around a young planet, dust and molecules dance out the recipe for new satellites, miniature stages where future geology and perhaps future chemistry will play out. Our world, meanwhile, keeps asking to be protected. NASA's instruments that roam the skies help scientists map how fires alter water supplies, how dust moves after an engine plume, how particles travel through our air. That knowledge helps a farmer know when to plant, helps a town understand the safety of its reservoirs, helps an emergency team decide where to put sandbags. The same curiosity that reads starlight becomes a tool of care on Earth. Now allow the narrative to fold in one more theme, the idea of apprenticeship and challenge. Challenges like the Human Lander Challenge are not only contests, they are classrooms with very public finals. They ask people to imagine the improbable and then make it real enough to test, to prototype, to fail, and to learn. Think of student teams whose hands are inked with schematics and whose whiteboards are full of scribbled equations. They are the ones who will iterate through failure to find something that works in the harsh vacuum and abrasive dust of the moon. Prizes and challenges push ideas forward, not by fiat, but by curiosity. As your breathing slows, imagine a single small scene that gathers all these threads into one gentle image. A young engineer sits before a screen displaying a glowing ring around a planet. On his desk is a plastic model of a lander. On the shelf, a faded photograph of the Grand Canyon. Beside him is a calendar with the dates of a student challenge he hopes to enter. Outside the window, a plane traces invisible ribbons in the sky as it samples the atmosphere. He thinks, quietly, of the future, of a person who will one day sleep under a thin dome on the moon, who will look up, not at clouds, but at a sky filled with Earth, and who will know that someone in a dusty lab once dreamed and sketched and kept going. He knows his work is small and essential. Stories like these are not all triumph. They are also full of patience and slow correction. Telescopes can mislead, and data can be ambiguous. Plans can be refined. What matters is the persistence of the people who care enough to examine the difficult parts and take the time to get them right. It is the same persistence that lets a child return to a puzzle until she understands it. It is the same quiet stubbornness that has led humans from carved stone to spacefaring craft. And now, for a last little voyage before sleep takes you. Imagine that the very dust that built those newborn planets someday seeded life elsewhere. Imagine also that our own small planet continues to require tending. The researchers who measure our air, the students writing code to manage life support, the dreamers drafting lander designs, the astronomers pointing Webb at a distant nursery. All are involved in a single, long labor of stewardship. The universe offers wonders without end. Our job is to learn how to reach them and how to live wisely beneath their glow. As your eyelids grow heavier, let the images settle like a soft film behind your eyes. See the golden honeycomb mirror of a great telescope, its facets catching faint infrared light. See the slow ring of dust around a distant planet, curled like a sleeping animal. See the new astronaut stepping out of a training pool, smiling at the absurdity and joy of it all. Hear, faintly, the hum of aeroplanes that check our air. Feel the gentle insistence of students and their challenges. Take one more long breath in now, and let it be full of stars and the cool chemistry of distant disks. Breathe out, releasing everything you have carried from the day. Lay your cares upon the pillow, and know for a quiet moment that human curiosity and careful tending continue all night and all day. People at observatories and centers of learning are awake in a different time zone, poring over small signals and long data sets. They will snooze, and they will wake, and they will continue the work that expands what we can imagine. Sleep now, explorer. Dream of moons being born in the lullabies of dust and light. Dream of engineers whose sketches become habitats. Dream of young astronauts who will one day float by a window that looks down on a sleeping Earth. When your eyes open again, the world will have spun a little further in its orbit, and perhaps a new image will have arrived to remind us that the cosmos is never finished telling its stories. Good night, from all of us here at Bedtime Universe. Hello, celestial dreamers, and welcome once again to Bedtime Universe. Tonight, we journey not to a distant nebula or a forgotten star, but to a moment in our very recent past. A moment suspended between profound discovery and profound silence. It is a story of a traveler from an unknown shore, an object that journeyed for eons through the interstellar dark, only to arrive at our doorstep at the most peculiar of times. This is a tale of a government that went dark, a space agency that fell silent, and an alien comet that kept its secrets as the world watched and waited in a state of suspended animation. So, find a comfortable position, let the noise of your day recede like a distant tide, and allow your mind to drift. Tonight, we explore the enigma of 3I divided by Atlas, and the unnerving coincidence that turned a scientific marvel into a modern mystery. Our story begins on a date now etched into the memory of a select few astronomers and space enthusiasts. October 1st, 2025. It began not with a bang, but with a quiet, administrative whimper. Across the United States, a budget impasse in Washington, D.C. triggered a full government shutdown. For most federal agencies, this meant furlough notices, locked doors, and a frustrating pause on public services. But for the National Aeronautics and Space Administration, NASA, it meant something more profound. It meant switching off the lights on humanity's window to the universe. At the Jet Propulsion Laboratory in Pasadena, California, Dr. Elias Vance watched as the sprawling campus emptied out. He was a mission planner, a man whose life was dictated by orbital mechanics and celestial timetables. His normally vibrant control room, a cathedral of data streams and cosmic chatter, was now hushed, populated only by a skeleton crew designated as essential personnel. Their job was not discovery, but preservation. To protect life and property, to keep the multi-billion-dollar spacecraft scattered across the solar system from falling silent forever. The International Space Station would continue to orbit, its crew safe. The Mars Reconnaissance Orbiter would keep flying, but the flow of information, the very lifeblood of science and public engagement, was being severed at the source. The main NASA.gov website was replaced with a stark closure notice. The endless stream of breathtaking images on social media ceased. NASA TV went off the air. A procedural silence, mandated by the arcane articles of the Anti-Deficiency Act, had descended. Under normal circumstances, this would have been a source of immense professional frustration. But these were not normal circumstances. For on this exact day, at this precise moment in the grand cosmic ballet, An object of immense scientific importance was gliding into the most opportune observation window humanity had ever been granted. Its name was 3I divided by Atlas. The 3I designated it as the third confirmed interstellar object ever detected. The first, 1I Oumuamua in 2017, had been a bizarre, cigar-shaped enigma that left scientists debating its nature for years. The second, 2I divided by Borisov in 2019, had been more comfortingly familiar, behaving much like a typical comet from our own Oort cloud. 3I divided by Atlas, discovered just 3 months prior on July 1st, 2025, was the next chapter, a new data point in a field of study so young it barely had a textbook. It was following a hyperbolic trajectory, the mathematical signature of an unbound object, a cosmic tourist just passing through. It was a physical fragment of another star system, a time capsule carrying the chemical fingerprints of its alien birthplace, and it was heading for a close encounter, not with Earth, but with Mars. The orbital geometry was a gift from the heavens. Between October 1st and October 7th, 3I divided by Atlas would make its closest approach to the red planet, passing within a mere 30 million kilometers. From Earth, the comet was difficult to see during this period, positioned at a low solar elongation, meaning it was lost in the sun's glare. Our ground-based telescopes were effectively blinded, but our robotic emissaries orbiting Mars had a front-row seat. They could observe the comet from a perfect side-on angle, unhindered by the sunday. This was the plan, a coordinated, multi-agency campaign. While NASA's assets were formidable, the European Space Agency, ESA, had been exceptionally transparent about their intentions. Their Mars Express and ExoMars Trace Gas Orbiter spacecraft were prepped and ready. Their mission, scientists had given interviews, their excitement palpable. They aimed to study the comet's coma, measure its outgassing activity, and hopefully capture spectra that could reveal its composition. The world of planetary science was buzzing. Then, the lights went out. As ESA's spacecraft began their meticulously planned observations, NASA's public-facing infrastructure went completely dark. Elias Vance and his essential colleagues could ensure the Mars Reconnaissance Orbiter, MRO, and its powerful high-rise camera remained operational, but they were legally prohibited from engaging in any activity not directly related to protecting the spacecraft. Science planning was a gray area. Public data release was out of the question. A veil of silence was drawn over NASA's entire Mars fleet. The contrast was stark and immediate. ESA continued to issue updates, their scientists speaking to media outlets about the ongoing campaign. From America, there was nothing. This asymmetry created an information vacuum, and, as is always the case, speculation rushed in to fill it. The internet, a place where curiosity and paranoia dance a tangled tango, began to buzz. Threads on Reddit and deep-dive videos on YouTube started connecting the dots. Isn't the timing a little too perfect? One user asked. NASA discovers something huge with 3I divided by Atlas and uses the shutdown as the perfect cover to classify it. The whispers grew into a roar. Claims began to surface, unverified but compelling. Some swore they saw raw image files from MRO briefly appear on a public server before being scrubbed. Others, examining pre-shutdown data, claimed to find evidence of unscheduled maneuvers, tiny burns from the comet that couldn't be explained by natural outgassing. The most tantalizing rumor centered on the comet's composition. Leaked whispers from anonymous sources hinted at preliminary spectra showing unusually strong nickel emission lines. Nickel, a metal, is not unheard of in comets, but the reported abundance was anomalous. This, combined with early mass estimates from Hubble data that were on the high end of the uncertainty range, painted a picture of an object that was far denser than a typical ball of ice and rock, a metallic monster, as one headline sensationally dubbed it. From his quieted station, Elias could only watch the storm of speculation unfold, a helpless bystander to the narrative being woven in the absence of fact. He knew the mundane truth. He had read NASA's continuity of operations plan. He understood the legal constraints, but he also understood the optics. The silence looked like concealment. The timing looked like a conspiracy. To understand the mystery, one must understand the competing hypotheses that bloomed in that quiet October week. They ranged from the mundane to the truly extraordinary. Hypothesis 1, the most likely and the most boring, was that of bureaucratic coincidence. The shutdown was a simple, unfortunate alignment of political failure and celestial mechanics. NASA's silence was procedural, not intentional. Any data collected was simply sitting in a queue, waiting for the shutdown to end and for furloughed scientists to return to their desks to process it. Nothing was hidden. It was just delayed. This was the explanation favored by Occam's razor. The simplest answer is often the correct one. Hypothesis 2 was the massive metallic core. This theory latched onto the nickel rumors and the ambiguous mass estimates. It proposed that 3I divided by Atlas was not a comet in the traditional sense, but a fragment of the iron-nickel core of a shattered exoplanet or large planetesimal. Such objects, called differentiated bodies, have heavy metals sink to their center. A catastrophic impact in its home system could have blasted a piece of this core into interstellar space. This would make 3I divided by Atlas a scientific treasure trove, a solid piece of the deep interior of an alien world. The implications for planetary formation and for future resource mining were immense. Hypothesis 3 was the shadow that had lingered ever since Oumuamua, the engineered or technological artifact. This was the most sensational theory, suggesting 3I divided by Atlas was not natural at all. It could be an active probe, a derelict spacecraft, or a piece of alien megastructure. Proponents of this idea, led by vocal astronomers like Avi Loeb, who had championed the same possibility for Oumuamua, argued that we must remain open to the possibility. Any non-gravitational acceleration not clearly linked to cometary outgassing, any structured light curve, or, the ultimate smoking gun, any coherent radio signals, would be evidence. No such evidence had been confirmed, but in the information vacuum, its absence was not enough to quell the speculation. Then came the deeper, darker theories. Hypothesis 4 suggested a third-party intervention. Could a nation with secret advanced space capabilities, the US, China, or Russia, have used the Mars window to conduct a covert rendezvous or inspection mission? It sounded like science fiction, but the theorists argued that a metal-rich object of unknown origin would be of immense national security interest. The shutdown would provide the perfect cover for such a clandestine operation. This bled into Hypothesis 5, black-budget data capture. This theory proposed that even if no physical intervention occurred, military and intelligence assets like the National Reconnaissance Office's spy satellites or the Space Force's advanced tracking radar had observed 3I, divided by Atlas. Their data, which would be far more detailed than anything NASA or ESA could produce, would be instantly classified. The public would never see it. The silence from NASA wasn't just a consequence of the shutdown. It was part of a coordinated effort to keep the real data under wraps. Finally, there was a more grounded scientific possibility. Hypothesis 6, a planetary interaction event. This theory suggested that the close pass by Mars itself triggered a transient event. Perhaps a gust of solar wind, interacting with Mars's weak magnetosphere, simultaneously hit the comet, causing a temporary, dramatic brightening or an outburst of gas that was misinterpreted by early observers. This would be a fascinating scientific discovery, an observable interaction between a comet and a planetary environment, but entirely natural. For weeks, these 6 narratives battled for dominance in the public sphere. Elias Vance and thousands of other scientists could only wait. The shutdown dragged on. The comet passed its perihelion, its closest approach to the Sun, in late October, and then swung behind it, entering a period of solar conjunction where it was completely invisible from Earth. The dead zone of the Mars window was followed by a natural blackout. Finally, in mid-November, the political stalemate broke. Funding was restored. NASA's websites flickered back to life. Furloughed employees returned, blinking in the sudden light, to face a mountain of backlogged work. For Elias, the real work could now begin. It was a process he called data rescue. He and his team began the painstaking task of retrieving, processing, and calibrating the data collected by MRO and other assets during the shutdown. Simultaneously, they began to coordinate with their counterparts at ESA, who were already well into their own analysis. The first pieces of the puzzle began to click into place. ESA's data from Mars Express was clean and comprehensive. It showed a clearly active comet with a coma and tail. The spectroscopy did confirm the presence of nickel, but at levels that, while high, were not entirely outside the realm of possibility for a comet formed in a metal-rich protoplanetary disk. There were no sudden, inexplicable maneuvers. The light curve was consistent with an irregularly shaped, tumbling nucleus, not a controlled, structured object. Then came NASA's data. After weeks of processing, the first images from MRO were released. They were not the crystal-clear, revelatory pictures the conspiracy theorists had hoped for. As predicted by the laws of optics, at a distance of 30 million kilometers, 3I divided by Atlas was little more than a fuzzy, overexposed blob at the center of a star field. The valuable data was in the photometry, the precise measurement of its brightness, not in its shape. And that data, when cross-referenced with ESA's, matched perfectly. Both agencies had seen the same thing: a comet, behaving like a comet. The final piece of the puzzle arrived in late November and December. As 3I divided by Atlas emerged from behind the Sun, a global network of ground-based observatories, from professionals in Chile to amateurs in their backyards, locked onto it. Its trajectory was plotted with exquisite precision. The orbit fit the model of a hyperbolic path, influenced by a slight but entirely normal, non-gravitational force, consistent with outgassing of volatile ices like water and carbon monoxide. There was no evidence of a high-density, metallic core deflecting its path. Radio telescopes, including a concerted campaign by the SETI Institute, scanned it relentlessly. They found only the quiet hiss of the cosmos. The grand mystery of 3I divided by Atlas resolved itself not with a shocking revelation, but with the steady, quiet accumulation of collaborative, verifiable data. The mundane explanation, Hypothesis 1, proved to be the correct one. The shutdown had been a deeply frustrating, scientifically damaging, but ultimately simple coincidence. The silence was not a cover-up. It was a consequence of policy. The comet was not an alien messenger. It was a fascinating but natural piece of another world. For Elias Vance, the experience left a lasting mark. The story of 3I divided by Atlas became a powerful lesson. It revealed the fragility of our scientific infrastructure and the critical need for transparency. In an age of rampant misinformation, silence from trusted institutions is no longer a neutral act. It is an invitation for the darkest, most compelling fictions to take root. The incident spurred a quiet but significant policy review within NASA about how to maintain a minimal, essential line of public communication during future shutdowns. 3I divided by Atlas continued its journey, fading back into the interstellar darkness from which it came. Its brief, chaotic visit to our solar system complete. It left no smoking gun, no alien message, but it left a legacy, a reminder that the search for truth is a global, collaborative effort, and that sometimes the greatest mysteries are not hidden in the stars, but in the human systems we build to observe them. And so, the traveler departed, leaving us with more data, more questions, and a profound lesson in the importance of an open dialogue with the cosmos. The mystery of 3I divided by Atlas was not one of alien technology, but of human communication. It reminds us that in the quest for knowledge, the greatest obstacle is sometimes not the vast distance between stars, but the walls we build between ourselves. A humbling thought to carry with you into your dreams. Thank you for joining us on this journey through the quiet corridors of space and policy. We hope this story has given you something to ponder as you drift off to sleep. Until our next celestial story, from all of us here at Bedtime Universe, keep your eyes on the stars and your minds open to wonder. Sleep well, and may your dreams be as vast as the universe itself. And now, as the night grows deeper and the world grows quieter, let us drift into our next journey. A story carried on the darkness above us, a story written in light. Tonight, we will follow what poets once called a river across the heavens, a gentle current of stars flowing silently through the sky. This story is called The Quiet River of Stars. Close your eyes and picture a place without the noise of lamps or screens. A place where the air settles cool on your skin and the horizon is a clean black bowl. In that bowl, the river appears soft, milky, faint at first, as if someone brushed white chalk from one horizon to the other. This is the band of our own galaxy seen from within, a sideways view of the spiral disk that holds us. People have named it for as long as we have looked up. A road of light, a milk spill of the gods, a path for souls, a sky river. Astronomers give it a simpler name, the Milky Way. But names are just doors. The wonder is what you feel when you step through. If your eyes are dark adapted, 20 minutes without bright light, no phone, no car, headlights, the band lifts itself out of the background. You begin to notice texture. The river is not smooth. It is threaded with dark inlets and quiet eddies where the light thins. Those are not holes at all, but lanes of interstellar dust, thin as smoke and wide as light years, drifting between the stars and absorbing their glow. Along the band are brighter knots and hazy patches where new stars are kindling inside clouds of hydrogen. Somewhere near the middle, low on a summer night in the south, the river swells into a soft bulge. That is the direction of the galactic center, toward the constellations Sagittarius and Scorpius, where the star clouds are dense and the dust lanes cut like long black rivers within the river. We stand on a small world circling a very ordinary star. Our sun is a yellow-white dwarf among hundreds of billions, set out on a suburban lane called the Orion Arm. Some call it the Orion Cygnus Arm, or simply the local arm, a minor spiral lane between two larger ones. Perseus on one side and Scutum Centaurus on the other. From this neighborhood, we look edge-on through the disk, and the light piles up, star behind star behind star, until the sky looks like spilled milk to the human eye. If you could jump out of the galaxy and look from above, you would see the disk as a broad spiral about 100,000 light-years across, with the sun not at the center but off to one side, roughly 26 to 28,000 light-years from the core. Numbers can feel large. Let them slow your breathing. A single light-year is the distance light travels in a year. The starlight taking shape as that pale band tonight began its journey long before your grandparents were born, and in some parts of the band, long before humans ever spoke. There is a black heart at the center, but not empty dense, a supermassive black hole we call Sagittarius A*, about 4 million times the mass of our sun, sits in the core like a city's weight under all the light. Around it, the bulge is crowded with old stars. Their orbits are tight, their dances swift. Astronomers have watched some of those stars loop the black hole in short centuries and decades, their paths bending under a gravity that is both invisible and absolute. You cannot see any of that from a dark field, of course. What you see is the echo. The middle of the river grows brighter and wider, and the dust lanes cut across it like slow thunderheads. Downstream and upstream from that swelling, the band thins and threads through the constellations like a silk ribbon. Through the tail of Scorpius, through the teapot shape of Sagittarius, up past the eagle Aquila, across the bright cross of Cygnus and its long tail to Deneb, curving toward Cassiopeia's crooked W in autumn, and back down through the horns of Taurus in winter. Listen to the quiet of that river. Beneath its light is a weather of gas and dust, mapped not by clouds and rain, but by faint glows at specific colors. Hydrogen, breathing in a deep red, we call H-alpha. Oxygen in a soft teal, dust grains scattering blue like smoke. The glow is not a roar, but a whisper. New stars form in cocooned nurseries. The Orion Nebula, a flowering knot in the sword of Orion. The Carina Nebula, bright and knotted in the southern sky. The Lagoon and Trifid in Sagittarius. Side by side, one, a wide pool of glowing hydrogen, the other, a pale blossom banded by dust. In those places, gravity gathers gas until the pressure and temperature rise high enough for hydrogen to fuse into helium and light, and a star is lit. For millions of years, radiation and stellar winds carve caves and pillars out of the clouds, and when the most massive stars end, they end with a generosity that shakes their neighborhoods. A supernova enriches the surrounding gas with heavier elements, the stuff of planets and rock and you. The river recycles. The river teaches the same old lesson softly. Endings and beginnings are parts of one flow. Where you stand matters. At mid-latitudes, the Milky Way arches like a great bridge from south to north in summer. In the tropics, the core climbs high, and the river thickens overhead, finer texture, more star cloud, more dark lane. In winter, the band tilts, and though the core is hidden on your side of the planet, the river still threads through Orion and Gemini, lace-fine and quieter. From the far south, different reaches are revealed. The Southern Cross standing near the riverbank like a marker. We forget, under city domes and office ceilings, that the sky changes with season and latitude. The river reminds us if we let it. The facts can be gentle if we speak them softly. The disk that makes this band is not flat as a plate. It is warped, as if a slow hand had lifted its edges unevenly. The sun and its planets ride a wavy midplane, dipping above, then below the disk, over tens of millions of years. Our star orbits the center at roughly 200 kilometers per second, and a full lap around the galaxy, the so-called galactic year, takes something like 200 to 250 million Earth years. Think of that. One slow turn of the river's wheel, and the calendar on your wall is emptied 1,000 times. In that span, continents drift, mountains lift and wear away, new languages are born and forgotten, and the sky rivers for every creature who looks up is both the same and not quite the same, because our vantage point is always moving, always slightly changed. Far beyond the disk are the globular clusters, old and round, each a ball of ancient stars, hundreds of thousands gathered into spheres that drift in the galaxy's halo like lanterns at a festival. They are not on the river itself. They are like lights hung in high trees along the banks, thick with red giants and blue stragglers. Their chemistry, old and spare. Look for M13 in Hercules, a hazy cotton knot with a steady heartbeat of stars. Look for 47 Tucanae in the south, a larger, brighter hive of sun candles, densely packed. Those clusters are fossils of early times. The river runs newer in the disk, where gas still pools and stirs. There is a quiet address you can memorize if it helps you sleep. You live in the local bubble, a kind of low-density cavity in the interstellar medium. likely carved by ancient supernovae long ago. That bubble overlaps with your neighbor's bubbles like soap suds, and on its walls, new stars have been born and will be born. You live in the Orion Arm, part of a barred spiral galaxy roughly a third of the way out from the center. Your sun is one of hundreds of billions. Many of those stars have planets. We know this now not as a guess, but as a repeated measurement, a song of small dips in starlight, of tiny wobbles and split spectral lines that mean a world is tugging. Somewhere, on some night under a different sky, someone could point up and trace their own river, and know that a small world is looking back, equally curious and equally tired in the good way of a long day's end. Turn your mind along the river's route, and let it walk by landmarks you may know in name even if you've never seen them raw. There is the Great Rift, a long chain of dust lanes running through Cygnus, dimming the river and dividing it into two pale streams. There is the North America Nebula, a red map of a continent in hydrogen glow. There is the Aquila Rift, a darker branch. The star clouds of Scutum, the small, bright M24, sometimes called the small Sagittarius star cloud, like a window where the dust thins, and you can see deeper than usual. There is the Pipe Nebula in Ophiuchus, a simple L-shaped darkness that stands out simply because it has the courage to be black against all that light. Each one is a piece of texture. Each one is a reminder that the river's softness is made of millions of hard-edged facts. If you lifted above the river, if you climbed out of the disk and looked back, the band would fold itself into a grand design. A central bar, spiral arms unwinding, star formation, tracing those arms like frost blooming along glass. Tidal interactions with small satellite galaxies tug on the edges. The Magellanic Clouds leave a stream of gas, like a wake on the galaxy's sea. Dark matter unseen, but weighing far more than all the stars, holds the whole structure together, an invisible frame carrying most of the mass. You do not need the details to rest. It is enough to know that the quiet you feel beneath the river is supported by something strong and steady. And there is a future even for rivers. Long from now, so far that it occupies the part of the mind where fairy tales live. The Andromeda Galaxy and the Milky Way will draw together. They already are. Andromeda is coming toward us slowly in human terms, and quickly in cosmic ones. In several billion years, the two spirals will begin to interpenetrate and merge. It will not be a crash of suns. The spaces between stars are so large that very few will meet head-on. Instead, orbits will reshape, gas will rattle and compress, bursts of star formation will ignite, and the final result will be a new, larger galaxy with a new shape, a new river. No one you know will be there to see it, but somehow the knowledge feels soothing. Even grand structures have arcs to their stories, and change at that scale is a tide you can let lift you into sleep. Perhaps you are listening from a city, and the river is hidden behind a dome of light. That is all right. Part of the story of this river is that it is patient. It has waited for eyes to look up in deserts and on ships, and in mountain meadows, and on quiet balconies, when the power went out and the night returned to its ancient depth. If you ever find yourself somewhere dark on a beach after the moon sets, on a hillside at 2 in the morning, on a ferry deck where the wind keeps you awake, give your pupils time. Turn off the lamp. Let the cones in your eyes rest. Let the rods take over. Let the glow sharpen. At first you will see grey. Then the grey will thicken into a woven cloth. Then a dark seam will run through it, and a bright knot will appear, and another, and the river will be there, in a way no photograph can quite teach. Breathe in, and let it lay a hand on your shoulder. If you want a simple ritual to bring you closer to the river from anywhere, try this. Imagine your mind is a slow raft. Set it upon the band of light and let it drift. As you float, count gentle truths instead of sheep. 1. The light of Deneb has been traveling for more than 1,000 years to reach you. It left the star when empires were drawing new borders on parchment and never stopped. 2. The sun is circling the galaxy. Tonight you moved many thousands of kilometers around the center without feeling a thing. 3. The atoms in your blood were made in stars. The iron in your hemoglobin was built in the core of a dying sun before the Earth existed. 4. Somewhere deep in the band are clusters where stars are born every year from dust and gas, their infant light pushing away the very clouds that sheltered them. 5. The river you see is the edge-on sum of 100 billion worlds, all real, all turning, all warming their own nights. By the time you reach 6 or 7, you will feel the river pulling on you in the way a lullaby does, not with force, but with belonging. It is not just sight that brings you into the river's quiet. There is the sense of scale, spacious in a way that gives room to whatever you carried to bedtime. A worry that filled your whole day can sit on the riverbank for a while, not gone but smaller against the spread of things. There is the rhythm of cycles, short and long, your breath, the beating of your heart, the rotation of the earth, bringing night and day, the sweep of the moon around us, tracing tides. The path of the earth around the sun, bringing seasons, the sun's path around the galaxy, bringing epochs, the galaxy's future dance with its neighbors, bringing transformations. Each cycle holds what came before. As you listen, you are held too. For those who like details tucked under the pillow, there are a few more to rest on. The disk of the galaxy is not just stars. It contains spiral waves, patterns where gas and dust compress and release as they orbit, like cars bunching and separating on a ring road. Where the wave compresses, star formation lights up, and the arm looks brighter. Between arms, the light softens, but does not end. The dust lanes are not dirty. They are the raw material for future light, and they redden starlight, passing through them the way a sunset reddens the Sunday. On clear, moonless nights, observers in very dark places can see the zodiacal light, a faint triangle along the ecliptic, sunlight scattered by dust within our own solar system, the Gegenschein, an even fainter brightening opposite the Sunday. These small additions are like fireflies near the bank, joining the river but separate from it. If rhythm helps you rest, we can set the story to 1. The river rises in the south, flows up through the Eagle, crosses the Swan's back, passes the Queen's chair, and falls again toward the Hunter's belt by winter, then settles, then returns. With every return, you are a little older, and so is the light you see, but the pattern holds. This is the part of astronomy that feels like a kind hand. The sky is not a puzzle to be solved and set aside. It is a companion you can visit. The more you learn of its facts, the more it rewards you with feeling. Knowing the name of a nebula does not steal its mystery. It adds a note to a chord you already love, and still, beneath all the texture and all the numbers, there is the simple act of lying back and letting the white band pour across you. Somewhere along that band, on a small world with a name we have not learned, another listener may be doing the same, letting their mind drift along their river, counting their truths, thinking their own future, and carrying their own day into the kind night. When you share the river, you share something large without needing to own it. The light is given freely. The time was paid long ago by the stars themselves. If you find your thoughts wandering to distances and durations, let them. Let the mind take a slow walk. Light crossing the space between stars, collapsing gas, warming into stars, planets taking shape from rings of dust, like snowflakes growing on a windowpane, oceans forming, air thickening, creatures lifting their eyes. None of this is rushed. The river has room for slow stories. Your story is one of them. Now the night grows deeper still, and the world grows quieter still, and the river goes on doing what it has done since before there were people. It gathers the light of uncountable suns into a band we can understand at a glance. Not everything has to be solved. Some things are here to be trusted. The Milky Way is one of them. You can rest beneath it without finish lines or arguments. It will still be flowing when you wake. So breathe in and breathe out, and let the quiet river of stars carry you. If your eyes are closed, Picture that soft band and the dark lanes braided through it. Picture the bulge low on the horizon, like a slow sunrise of far-off suns. Picture the way it arches up and over, east to west, season to season, age to age. If your eyes are open and lucky enough to be in the dark, let the band have you whole for a minute. Let it make every small noise in your life seem smaller, and every kind thought seem larger. In the end, that is what the river is for. It is a reminder that we live inside something vast and patient and ongoing, and that our days, bright, messy, dear, are carried along by a current we can trust. When you are ready, you may set your raft against the bank and step into sleep. The river will be here when you drift back in the morning. It always is. It always has been. Good night. May the hush of the galaxy be the hush of your room. And may the quiet river of stars guide you gently, steadily, all the way into rest.